And we're back again, Calc BC. It's weird because I just finished the other video, but we got to break this up into a couple of days. So yeah, that was kind of funny. Anyway, so it's probably what, Tuesday, Wednesday, and we're checking this one out. We reviewed all the logarithm stuff, the exponential rules, and hopefully that went pretty smoothly for you guys. We'll talk more about it in class if you have questions. Today, though, it's all about trigonometry. Today is a big trig day. Yeah, so we are into the trigonometry rules and for deriving. And this time, you know, I'm going to hit both the trig rules for just regular functions, sine, cosine, tangent, all that stuff. Just a reminder of all those. And then we're also going to hit all the inverse trig functions. So how to derive all those. And so it's a lot of just remembering that there's different rules for the various functions. And then we'll kind of have the whole, if you look in the front cover of your textbook, I mentioned it in the last video, there's 22 derivative formulas up there. So after today, we will have basically reviewed all 22 of the kinds of derivatives you are supposed to know how to do. Do you need to memorize all 22 of those? Yes, you need to memorize all 22 of those. There's really no way around it. You know, obviously, in this environment, when you're at home and you have your books and your notes and everything right there with you, you know, there's the tendency to want to lean on those, and you know, that's okay. As I had a great physics professor that said, you know, we do everything once, so it's in your notes, and then you know where to look it up, which I kind of like that. It's a good way to think of it. But we still need to know how to do these ones. They should be quick. It's kind of like multiplication facts. You know, if you're busting out your calculator to do 5 times 4, you know, yeah, grab your calc book and hit yourself over the head with it. So that's not necessary. All right. Don't really do that. That's being facetious. Trig functions. Let's start with the basics, right? And so I'm going to use some Leibniz notation for trig functions. So let's say, you know, y is equal to sine of x. Y is equal to cosine of x, right? So what do we know? We know dy dx for sine, right? Cosine. And dy dx for cosine, negative sine of x. Okay. We can keep going because now that we know the quotient rule, right, from last week and everything, so if y is equal to tangent of x, dy dx is equal to secant squared of x. Okay. And if y is equal to cotangent of x, dy dx is equal to negative cosecant squared of x. Right? And hey, while we're at it, if y is equal to secant of x, dy dx is secant x tangent x. And if y is cosecant of x, well, you know, dy dx is cosecant cotangent. Sorry, negative cosecant x cotangent x. Don't want to forget that negative sign. All right. So yeah, those are your 6 main trig functions right there, and how to derive them. And we've probably actually already seen a few of those crop into the homeworks as I've gone through. But just a nice place to kind of put them all together. You know, and then today we're also going to talk inverse trig functions. So what color should we do inverse trig functions in? What do you guys feeling? Green? Sure. All right. Inverse trig functions are a little bit more complex because you know, they're a little bit different functions. Inverse trig functions. And so when we look at the derivative for the inverse trig functions, you know, they're not nearly as simple as those were. So for example, right, you know, if our function, if f of x is arc sine of x, okay, well then the actual derivative of that function is not a trig function. It's a weird kind of radical, right? It's 1 over the square root of 1 minus x squared. You know, if f of x is the arc cosine of x, well, the nice thing is the pattern continues, right? The co-ones are all negative. So, you got that going for you. If f of x is the arctan of x, our derivative is a rational function, right? F prime of x is 1 over x squared plus 1. And I'm going to skip the cotangent one. It's just the negative, right? If f of x is the arcsecant of x, right? Then the f prime of x is going to be a 1 over the square, or x times, well, okay, 1 over the absolute value of x. Times the square root of x squared minus 1. And now these were all x. If there's a u, function of u in there, right, then you're going to multiply all these by u prime. So a lot of times just a u prime in the numerator. Yeah, so the inverse trig functions were a little bit more complex, right? And so, and that's because, what do they actually mean, right? These are the inverse trig functions. So yeah, the graphs for them are a little bit more complicated, largely because of the cyclical nature of the waves, So anyway, it becomes a little bit more complex problem when you're looking at the slope or the rate of change of the inverse trig function. So there we go. Those are the rules. So if you go over to the front cover of your textbook, let's go over there right now, and take a look. You're going to see that we have completely reviewed all 22 of these rules. Each and every one of these has a u in it so that you can remember that we are doing the chain rule. So every single one of them is the derivative is taken with respect to x. Of course, down here you'll see dx on all the functions, on all the derivatives that we've got. Okay, but the function that's inside is never just x. It's always either a constant or it's two functions multiplied together or whatever. And a lot of times they use u, like here, natural log of u, to remind you about the chain rule. So these 22 functions and their derivatives are pretty important. And like I said before, do you need to memorize them? Yeah, you kind of do. It's gonna it'll help you in the long run. You don't want to be fumbling around looking through your notes when you're trying to find the derivative of cotangent. It'll just be easier if you have it memorized. So that's it for today, guys. I will see you in class on Thursday. Have a great day, whether it's Tuesday or Wednesday or whatever day it is. And we'll go through any questions you have on these rules and look at some more applications as we get set. So there we go. The derivative rules quiz will be next Monday. So let's make sure we have all 22 of these rules pretty solidified before that. All right. Have a great day, guys.